In this video, I will show you how to represent a system of equation using matrices. The first thing you must do is rewrite each equation in standard form. That's x, y, z equals a number. The first equation is already in standard form, so that's great. 3x plus y minus z is equal to negative 19. The second equation is all out of order. This x needs to come over here, and this y needs to come over here. Now technically we are subtracting x from both sides and subtracting y from both sides. That's why I will have negative x minus y and then plus 3z is equal to 21. Now this equation, the last equation, the 7 needs to go over there. So we will subtract the 7 from both sides. That's why we will have negative 7 on the right. Now these three are already on the correct side of the equal sign, but the z just needs to scoot to the right of the y. Because we are not moving it past the equal sign, we are not going to subtract z. It will not change signs. So we will have 2x plus 2y plus z is equal to negative 7. Alright, now we can rewrite this system of equation as a matrix equation. We will take the coefficients of all the variables to form the coefficient matrix. So we will have 3, 1, negative 1, and then negative 1, negative 1, 3. You see where I'm getting these from? What will the last one be? 2, 2, and 1. So this is the coefficient matrix. Now this will be multiplied by the variable matrix, which will just have all the variables, which in this case is simply x, y, and z. And then we will set that equal to the answer matrix, the constants, so negative 19 and 21 and negative 7. So this is a matrix equation that would represent the original system of equations. Let's practice again. Problem number 2 looks a little bit odd because I see that we have x's, y's, and z's, but each equation is missing one or more variables, so we will have to leave space. So for example, this first equation is already in standard form, but we're missing a y. So that's why when I make my coefficient matrix, for the top equation I will have 3 and then 0, okay, that's the coefficient of the y term, and then 1 for the z. Okay, now for the second equation we just have the y term, which would be in the middle. There is no x term and there's no z term, so I'll put zeros for those. But negative 5 is the coefficient of the y. And for the third equation we are missing the z term. So I will put 1 for the x and negative 2 for the y and then 0 for the z term. So this is going to be my coefficient matrix. Alright, my variable matrix is still going to be x, y, and z because we had all three of those variables, and that will still equal the answer matrix full of the constants 5, negative 25, and negative 12. So that's how you could write number 2 as a matrix equation. Okay, now this is going to feel really silly. Alright, I can hardly bring myself to write this as a matrix equation because why would we when the we already have the solutions? But you know what, I'm going to do it anyway. So we have these four variables, w, x, y, z, in that order. So for the first equation, all we have is w. So that would be a 1, and then a 0 for the x, a 0 for the y, and a 0 for the z. And then for the second equation, all we have is an x. So that would be 0 for the w, 1 for the x, 0 for the y, and 0 for the z. And then similarly, we have only a y. So that's going to be a 0 for the w, a 0 for the x, a 1 for the y, and a 0 for the z. And then finally, we have only a z. So that would mean a 0 for the w, a 0 for the x, a 0 for the y, and a 1 for the z. So this is the identity matrix, but that's what we would have in a strange situation like this. And we could multiply that by our variable matrix. Whoops, put x first, but this time we have a w first, so w, x, y, z, and that's going to equal the answer matrix full of the constants. What was it? -1, -3, 0, and 4. So this would be the matrix equation for this system. Alright, for the next couple problems, they want us to go the other way. And so we're going to write a system of equations represented by each matrix equation. Alright, so clearly these are the variables, these are the coefficients. So my first equation would be 2a plus 3b minus c, alright, there's the -1, is equal to 1 from right there. Now looking at the next line, I've got 3a plus 4b plus c, that's the 1, is equal to 6. And then the last row gives us -a minus b plus 2c is equal to 7. So there's a system of equations that would be represented by this matrix equation. Okay, let's do it again for number 5. Notice for the zeros here in the coefficient matrix, we will not put any term at all. So we have t, r, and s in that order. So for the first row, we will have t, and then we will have no r's, and then we will have -2s. Okay, and that's going to equal, of course, -3. For the next equation, we have no t because of the 0. So we will just have a -3r and then 4s. So plus 4s is equal to 0. And then for the last row, we have all three variables. So I will have -t plus 5r plus 2s is equal to 5. So there's a system of equations represented by this matrix equation. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.